Welcome everyone to another class in the subject CE 405 Environmental Engineering 1. So in today's class we are going to discuss what are the different forms of chlorination. So we already discussed what is disinfection, what are the different methods of chlorination, etc. So today we will be discussing what are the various forms of chlorination. So based on or depending upon the stage at which the chlorine is applied to water, chlorination may be divided into the following forms. They are plain chlorination, pre-chlorination, post-chlorination, double or multiple chlorination, breakpoint chlorination, superchlorination and dechlorination. So we'll discuss each of these in detail. So coming to plain chlorination. So plain chlorination is actually the application of chlorine to plain water or say raw water as the water enters the distribution system. So we know that after the treatment process, starting from the screening, the sedimentation, the filtration, etc. So after disinfection, finally the water will be supplied to the consumers through the distribution network. So plain chlorination is actually the application of chlorine to the raw water as it enters the distribution system. So it also includes the chlorination of water that is present or stored in the tanks or in storage reservoirs in order to prevent the growth of various organic matter like algae, fungi, bacteria, etc. And this method effectively removes the color and odor from the water. So if water has any sort of color or there is some odor in water, it may be removed by the process of plain chlorination. So this is actually in this case, that is in the case of plain chlorination, the normal dosage of adding chlorine is between 0.5 to 1 parts per million. Then it is also used for untreated water which has a turbidity which may be relatively clear and also which has a turbidity less than 20 to 30 parts per million. So this is plain chlorination. Coming to pre-chlorination. So pre-chlorination, as a word itself says, it is previously applying chlorine. That is, it is the application of chlorine to water just before the treatment. For example, just before filtration, or even sometimes chlorination is done before the raw water enters the sedimentation tank. Even before sedimentation, the chlorination may be done. So this actually helps in reducing the amount of coagulants that are required because what happens is when chlorine is added, the organic matter will get oxidized. So it will reduce in effect the amount of coagulant that is required when it is added prior to sedimentation process. Also in alkaline water, the chlorination may even be done before the process of aeration. And here again the dosage of chlorine should be so adjusted such that the water has a chlorine residual of say 0.1 to 0.5 parts per million. So as it enters the filter plant. So pre-chlorination means it is the application of chlorine before any treatment, maybe before filtration or even before sedimentation. The main advantages of doing this process or the pre-chlorination process is that it reduces the quantity of the coagulants, like I said, by oxidizing the organic matter, and also it reduces the amount of the load of bacteria on the filters, and also thus when you reduce the load, what happens is the filter will run for a longer time, and it also controls the formation of algae and other planktons in the filters, and also it will eliminate the odor or taste that are present in water. So that is pre-chlorination. It is application of chlorine to water just before the treatment process. Now coming to the next type, that is post-chlorination. Post-chlorination means post treatment. So if the chlorine is applied to water after treatment, we call it as post-chlorination, and it is actually a standard form of chlorination wherein the chlorine will be added to water as it will leave the filter plant and also before it enters the distribution system. So just after filtration, before it is being distributed, the chlorination can be done. So this process of adding or applying chlorine to water after the treatment process is known as post chlorination. And here again the dose of the chlorine should be such that the residual chlorine in water should be about zero. 0.1 to 0.2 parts per million as the water enters the distribution system. So we know that residual chlorine or some amount of chlorine has to be present in water even when it is passing through the distribution system, and this is mainly to prevent or to protect the water from further contamination due to any other reasons like leakages in the distribution system or due to any other cross connections. So this is what is called as post chlorination. Now coming to the next type, that is double or multiple chlorination. So double or multiple chlorination actually refers to the application of chlorine at various stages, say more than two or even more other stages during the process of treatment of water. So usually the double chlorination will be adopted, or it is usually done when just before the water will enter the sedimentation tank and also after it leaves the filter plant. And this is usually done when the water has it is highly contaminated and also contains large amount of bacteria or other any other harmful organic matter. And the advantages of this method of double chlorination or multiple chlorination will be similar to that of pre-chlorination. So also in addition to this, the maintenance of the two chlorinating plants will serve as a safety factor. So that's about double chlorination, application of chlorine at two or more points during the process of water treatment is known as double chlorination. Now coming to the next one, that is breakpoint chlorination. So whenever chlorine is added or applied to water, mainly two things happen or two actions takes place one after the other. The first thing is that after we add chlorine, it will kill the bacteria that are present or the harmful pathogens that are present in water, and thus disinfection will be effected. And the second thing that it does is it oxidizes the organic matter that are present in water. So whenever we add chlorine to pure water which has no chlorine demand, so when do we say that water has chlorine demand? Chlorine demand happens whenever there is a need to oxidize organic matter or any other matter that are present in water. So whenever there is we add chlorine to pure water which has no chlorine demand, as you see here in the figure, a curve like that line you see A in this figure will be obtained. You can see this is a graph plotted between the applied chlorine and the residual chlorine. So it is a relationship between applied chlorine and residual chlorine. So when chlorine is added to pure water which has no chlorine demand, we can see a curve such as line A as you see in the figure. However, we know that water generally water will have chlorine demand, isn't it? Every water, whatever it is, after treatment also it will have a demand for chlorine. So then that will be resulted as shown in the curve B. So this curve will be obtained between the residual chlorine and the applied chlorine. So what happens is the chlorine will first perform the function of removing the bacteria. The first step when you add chlorine to water is it will remove the harmful bacteria or it will kill the bacteria. And during this process, during the disinfection process, the amount of residual chlorine will be less in the beginning. So that is marked by stage 1. So here you can see in the figure stage 1. This is stage 1 here. So what happens is in the beginning, as soon as we add chlorine, what happens is during the process of disinfection, the residual chlorine that will be present will be less, and that is what is shown in stage 1. So during this process, various chemicals like the exchange of such as ions of ferrous iron or sulfides or nitrates that are present in the water will be oxidized. And also you can see that this figure again there is another stage, that is stage 2. So during stage 2, the combined residual chlorine will actually increase as the demand for disinfection will be satisfied. So that is what you see in stage 2 as you see here in the figure. In this stage, that is in stage 2, the combined residual chlorine that will increase gradually because there is a demand for disinfection that is being satisfied, and this will keep increasing until it reaches a point C. So it is at the point C where the amount of the combined residual chlorine will be maximum. So here you can see the residual chlorine is maximum. As you see in the figure, it will be maximum at the point C. And here when the residual chlorine is maximum, what happens? There will be bad taste and also odor that is present in water. So they will reach a stage where water will be accompanied by bad taste and odor, and this stage 2 actually reflects the forming of combined residuals, as ammonia or amines will react with HOCl that has already formed. Now again, when we increase the amount of applied chlorine, that will result in the decrease in the residual chlorine, indicating the beginning of the second action. So after the disinfection process, next process is the oxidation of the organic matter. So after point C, when we further increase the amount of the applied chlorine, that will result in the decrease in the residual chlorine because oxidation process has already started. So during this action, the relation between the applied chlorine and the residual chlorine will be represented by the curve CD, as you see. So there will be a dip in the curve. So it is represented by the curve CD. So here the free chlorine will break down chloramines and by changing them to nitrogen compounds, while the chlorine residual actually will drop or fall. Now at point D, what happens is the bad smell and the taste will disappear, and oxidation of the organic matter will also be complete. So when you reach this point D, what happens is the bad smell will disappear. So we can say at point D the oxidation process is complete. So the residual chlorine has its minimum value at point D. So when we add further applied chlorine, it will again result in the increase in the residual chlorine. So beyond D, when we again add when we apply chlorine, what happens? It will again increase the amount of residual chlorine, which is represented by the line E. The point D on the curve is actually known as the break point, because further addition of chlorine will break through the water and appear as residual chlorine. Hence we call it as break point. So how will we define break point? So the break point in the chlorination of water may be defined as the point on the applied residual chlorine curve at which all or nearly all the residual chlorine will be free chlorine. So at this point D, all the chlorine that is applied will be free chlorine. So free chlorine residual is that part of the total residual that is remaining in water, and this point D, we call it as the break point or break point chlorination or free residual chlorination. It has actually great significance because application of chlorine at a very less level or a high level than the breakpoint chlorination will have advantages like removal of the taste and odor. Then it will have adequate chlorine residual. So there will be increase in the amount of residual chlorine beyond the point or beyond the break point. And also it will completely oxidize the ammonia and other compounds that are present in water. It also will remove the color due to the organic matter, say by 30%, and it also removes minerals like manganese, etc. So this breakpoint chlorination or the breakpoint stage can be determined by various laboratory tests. So I hope the concept of breakpoint chlorination is clear. Now coming to the next type of form of chlorination, that is superchlorination. So superchlorination is actually the application of chlorine beyond the stage of the break point. So when we add chlorine so as to give a residual chlorine content of say 1 to 3 parts per million, it has actually proved to destroy the odor and the taste that results from the chloro products that are formed between the decomposition of vegetable matter and as well as the algae that are present in water. And also this process of superchlorination is actually adopted whenever there is a breakdown or breakout of an epidemic, or whenever the water is liable to sudden fluctuations in chlorine demand, etc. So normally whenever there is a breakout of epidemics, we adopt this process of superchlorination, that is the application of chlorine beyond the stage of breakpoint. Coming to dechlorination is nothing but the process of removing the excess chlorine that are present in water before it is being distributed to the consumers or to the users, and this is to avoid the taste of chlorine that is present in water. We know that normally in public water supply, sometimes there may be a smell or even you can feel the taste of chlorine when it is present in excess. So the process of removing the excess chlorine from water, we call it as dechlorination. So it is usually done in such a way that some residual chlorine still remains in water. We know that presence of residual chlorine is very much needed. So even when we do the dechlorination process, it has to be noted, or it should be taken care that residual chlorine will remain in water. And dechlorination is achieved by various processes like aeration process, or even by using some chemicals which will effectively remove the excess chlorine that are present in water. So that's about the different forms of chlorination. Now moving to the different factors that affect the chlorination process. So whenever the pathogens in water are destroyed by the chlorination process, or the destruction of the pathogens by the process of chlorination depends on various factors like the turbidity, the presence of compounds, metallic compounds, ammonia compounds, the pH of water, the temperature, the time of contact, and also the number of concentration of the bacteria. So we'll see that. So firstly, the factor that affects the efficiency of chlorination is turbidity. So the effect of turbidity is that it makes it difficult to obtain free residual chlorine. So whenever the turbidity is high, what happens is it is difficult to obtain the free residual chlorine that is present in water. Also, the penetration of chlorine and the destruction of bacteria and the particles of suspended matter of turbid water. Whenever the water is turbid due to the presence of various matter or suspended matter, what happens is the penetration of chlorine and also the destruction of the bacteria that are present in the suspended matter will be very uncertain, and so thus it affects the process of chlorination. So usually we do apply chlorine only after removing the turbidity if it is present in water. Now coming to the next one, that is presence of metallic compounds. So whenever there is presence of metallic compounds like iron, manganese, etc. In water, it will utilize large amount of chlorine to convert them into higher stages of oxidation. So hence it is very much essential to remove the matter like iron or manganese from water to make chlorination useful and more effective. And now coming to the ammonia compounds, the presence of ammonia with or without organic matter may form some combined available chlorine which is not so effective which does not effectively produce free available chlorine. So ammonia will form combined chlorine compounds which are not very powerful as compared to the free chlorine that is present in water. So therefore more chlorine will be added so that after formation of the chloramines, excess free chlorine will be available for speedy disinfection. So ammonia compounds, presence of ammonia compounds is not desirable. Now coming to the next process, that is next factor that affects the chlorination process, that is pH of water. So as the pH increases, what happens is it reduces the effectiveness of chlorine. So up to 6.7, 95% of the total free chlorine. Then at 7, the pH of 7, 80% of total free chlorine. At 8, 30% of total free chlorine. And at 9, 5% of the total free chlorine, that is amount of hypochlorous acid. We can see that the increasing pH will reduce the effectiveness and also the effective sterilizing compound. We know that when bleaching powder dissociates mixes with water, it dissociates to form hypochlorous acid. So hypochlorous acid is actually the compound which affects the chlorination process. So the effective sterilizing compound is HOCl. So this will be formed in greater quantities at low pH than at higher pH. So this is how the pH will affect the process of chlorination. Coming to the temperature of water, so reduction in the temperature of water results in decrease in the killing power of both the free as well as the combined chlorine. So in order to have 100 percentage bactericidal activity, the requirement of the residual chlorine increases with the decrease in temperature and also increase in pH. Time of contact. So this is another factor. The bactericidal activity of the chlorination is not instantaneous. It's not sudden, isn't it? So it is actually the contact time of chlorine in water which effectively leads to the disinfection process, and the percentage bacteria that and the viruses that are killed depends upon the contact time between the chlorine and the microorganisms. So before the water is being supplied to the or distributed to the consumers. So the time of exposure or time of contact is very much needed, and usually for free chlorine 10 minutes time is required as compared to 60 minutes for combined chlorine. So time of contact is another factor which affects the process of chlorination. The nature and the concentration of bacteria and viruses, of course the types of bacteria and viruses also is a factor which depends upon the chlorination process, or which affects the process of chlorination. So that's all regarding the various forms of chlorination and the various factors that affect the process of chlorination. Thank you.